If you've ever stared at a screen, trying to get started with machine learning and just felt totally overwhelmed, this is for you. Today, we're going to pull back the curtain on Scikit Learn, this powerhouse library that looks so complex from the outside. But here's the secret. There's a simple, brilliant idea at its core that makes everything just click. So, what's our game plan? First, we're going to look at the blueprint that makes the whole library so ridiculously consistent. Then, we'll get our hands dirty with data prep. After that, it's a whirlwind tour of the awesome models you can build. And finally, we'll snap all those pieces together into your first complete project. Sound good? Let's do it. Okay, before we even touch the flashy algorithms, we have to understand the philosophy behind it all. Seriously, think of this as the master key. Once you get this one simple idea, the entire library just opens right up for you. And here it is, the estimator. I know, it sounds a little technical, but it's really just Scikit Learn's fancy name for anything that can learn from data. A tool that cleans your data? That's an estimator. A model that makes predictions? Yep, also an estimator. This is the one concept to rule them all. It is the universal building block for everything we're about to do. Now, what's so brilliant is how you use these estimators. It's always the exact same simple three-step dance. You can see it right here. 1, you import the tool you need. 2, you create it or instantiate it. And 3, you show it your data using the .fit method. That's it. Once you learn that rhythm, you can use pretty much anything in the toolbox. And this consistency, it's Scikit-Learn's absolute superpower. I mean, look at these 3 methods. .fit tells the estimator to learn. .predict, ask it to make a guess. And .transform tells it to change the data. It's kind of like learning how to drive a car. Once you know the gas, the brake, and the steering wheel, you can drive almost any car out there. You master these 3 commands, you've unlocked the whole library. Okay, so we've got our blueprint. Now, what do we build with it? Well, every single machine learning project starts with the same raw material, data. So let's see how Scikit Learn helps you find that data and, more importantly, get it ready for your models. And if you're thinking, but I don't have any data to practice with, don't worry, Scikit Learn has you covered. The library comes with this awesome built-in toy box of classic data sets. You want to classify types of wine, predict cancer, recognize faces? It's all right there, ready to go with just a single line of code. It's the perfect playground to start experimenting. But let's be real for a second. Your own data is probably never that clean, right? It's messy. It's got text, missing numbers, all sorts of stuff. The problem is, our models are picky eaters. They only want clean, organized numerical features. That gap between messy reality and clean math, that's where data preprocessing comes in. And Scikit Learn gives you an entire arsenal of tools, which are, you guessed it, more estimators, to bridge that gap. Now, this is where it gets really, really clever. You don't have to do all this cleaning one step at a time. Scikit Learn lets you build what's called a pipeline. Think of it like a conveyor belt that takes your messy, raw data in one end and spits out perfectly clean features at the other. And the best part? The entire pipeline, with all its steps, acts as a single estimator. You just .fit it once. It's so efficient. All right, our data is prepped and ready to go. Now it's time for the main event, the models themselves. We're going to do a high-speed, rapid-fire tour of all the different kinds of problems you can solve. First up, clustering. This is what you use when you have a big pile of data, and you want the machine to automatically find the natural groups hidden inside it, without you telling it what the groups are. Scikit Learn has amazing tools for this, whether you're finding simple blobs or really complex, weirdly shaped clusters. And, of course, each one is just another estimator that you can .fit to your data. So what if your data is just too big? I mean, too many columns, too much noise. That's where decomposition comes in. You can think of these tools like a data compressor. They are brilliant at boiling down thousands of features into just the most important, most essential patterns. It's perfect for simplifying your problem and finding that signal hidden in all the noise. And now for the big one, making predictions. Scikit Learn basically splits this into 2 big categories. You've got classifiers, which predict a label, like spam or not spam, and then you've got regressors, which predict a number, like the price of a house. The library is packed with models for both, and it's so well organized that it even gives you tools to check what type of model you're working with. Okay, so we've seen the blueprint, we've seen the data tools, and we've seen the models. So how in the world do we snap all of these pieces together to build something real? Let's walk through the complete workflow, start to finish. You know, this quote from Aristotle really says it all, because every single piece we've looked at, the data cleaners, the compressors, the models themselves, they all speak the same simple language of .fit, .predict, and .transform. And because of that, putting them all together is just incredibly elegant. And here it is, the whole journey from start to finish. Step 1, you load your data. Step 2, you build a pipeline to prepare it. Step 3, you fit a model to learn from that clean data. And step 4, you score the model to see how well you did. It's this clear, repeatable process that you can use for almost any machine learning problem you can think of. And this right here is the final beautiful insight. Every single one of those steps we just saw, the pipeline, the model, it's just another estimator. They're all different Lego blocks, but because they share that same simple shape, that same simple interface, they all snap together perfectly. That's the real magic of Scikit Learn. It's this entire universe of powerful tools all built on one simple, consistent idea. So there you have it. We've just toured one of the most essential and honestly, one of the most beautifully designed toolkits in all of modern technology. We've seen how a single design pattern, the estimator, unlocks a universe of possibilities. So really, the only question left is, what problem are you going to solve first?